Mic check 1 2. Okay, let's actually turn the output down slightly from 9,000. Let's go to 6,000 because I think that was better for YouTube streaming and doesn't use up quite so much CPU. Mic check 1 2. All good. Okay. Right. Wait for the views to pick up a little bit first. No viewers yet. Weird. Alright. Okay guys, so if you were with me last night and you will remember that we did a big repair on a Sundown SCV-6000D. Repaired the power supply section, power supply drive circuit, repaired the output section, repaired the output drive circuit, and everything seemed to be really good. And then when we hooked it up to put it back in the case and powered it on again, it was making some really strange issues with the output section. It was jumping to negative rail when the thing started to come to life, and I kept power cycling it, turning it on and off and trying to work out I think what was going on. And then eventually one of the power cycles, when I turned it on, a whole bunch of FETs exploded, and that was the end of that. Now this is really strange. At the time I thought that perhaps it was because the drive ICs weren't soldered particularly well to the driver board. I remember that there wasn't much solder on the pads, and even though I went through with my tweezers and I tried to wiggle the legs and they were very well soldered, they didn't move or anything like that, I thought, okay, well perhaps one of them had come off the solder pad because there wasn't a lot of solder there in the first place. So I was like, okay, I thought my bad. And so I went ahead and removed the driver board. This morning I've removed the driver board and resoldered, put some nice fresh solder pads on all the FAN drive ICs and put it all back together, and I have the exact same issue, but this time obviously I've not let it explode. This amplifier will go through some power cycles. So if you weren't with me last night, then here is the video. So just for you guys that the 66 Bud was with me last night. So for those of you who are watching just now, let's see how many viewers have we got. We've got 6 viewers. So for those of you that are watching me just now that weren't with me last night, here is the situation that happened last night. So let's go and view this. Here we go. Yeah, so this, I'm just going to press play on the live stream from last night, and you can see exactly what happened, and you can see the FET explode, and I'll explain what's going on in just a moment. Shit, I just realised that there's no desktop audio. Sorry, guys. Why is the desktop audio not working? One moment. One moment. Properties, default, speakers, Realtek. Okay, there we go. So sorry that you weren't getting any sound then, I just realised. So basically, yes, this is what the amplifier was doing on my live stream last night. I suppose you didn't really need any audio there, but yeah, basically this is what it was doing. It was dropping to negative rail on the speaker terminals as soon as you fired it up. Yeah, I'm not too happy with that at all, actually. I wonder if it needs more current to start up with. Nah, it should not be doing that. Okay, what's happening on the heatsink? Is there any spikes on the heatsink? Nope. Okay, I don't like that one bit. Why has it decided to start doing that now? Let's give it 12 volts worth of input, try it again. Wait for it, guys, it's coming. Maybe that's just what it does. I'm going to go for 14 volts now, 14.7 volts. It kind of really does spike when it turns on. Something's getting smelly as well. So that's a big spike to negative rail, and that shouldn't be there. So watch what happens as I keep power cycling it. Whoa! So yeah, there obviously was a fault there then, because that has just exploded. So there is something still wrong with this amplifier that we haven't quite figured. So let's watch that bit again. We were power cycling the amplifier like this. There's a massive spike to negative rail for some reason. I go over and I check to see whether it's shorting to the heatsink, to see whether there's any DC on the heatsink. Doesn't appear to be. Power it up once more. Whoa! And then the next power up results in explosions. So this morning, what I've been doing is I obviously had to pull the whole thing apart and repair it again, repair the output section again. Luckily it didn't take out any of the drive circuit, it just damaged the output FETs. So the output FETs, there were quite a few that were dead. I think there was 3 or 4 that were dead from that explosion. And I obviously put new FETs in, and it works really good now. I haven't put it back together fully yet, okay? But what? So this is something that I never would have thought, and this is a really strange coincidence. So I'm going to go ahead, and this is the same as last night. I'm going to turn the amplifier on again. So let's take my oscilloscope probe here, okay? The only difference is that there is something different. There's something missing from the amplifier at the moment. So this is how I repair the amplifier. I slid the board out of the heatsink, and I left the preamplifier board in there. So when I repaired the amplifier on the bench, it didn't have the preamplifier board with all the RCA inputs attached to the board. And then when I put it back together, obviously that made a connection, and then I did have the preamp board attached. So what I'm going to do now is I'm just going to power it up for you guys so you can see the thing actually works perfectly fine. 5 amps going in there. So it comes on beautifully. There's no longer I'm actually just going to turn the voltage down from 13.4, I don't need it that high anymore. It comes on beautifully. There's no spike to DC rail and to negative DC anymore on the power up. So if I go again, it's a really smooth, clean turn on. No funky sounds from the amplifier. I can power cycle it as many times as I like, and it works perfectly. However, the second that I slide the preamplifier board in with all the switches, knobs and LEDs etc. in, it does the same thing as last night. It spikes to negative rail and will probably blow a FET again. So what I think is, there is a probably problem with one of the input op amps on here. Let's take a zoom in here and have a look. Where's my zoom? Oh, my zooming camera seems to have frozen. One moment. See if I can fix that real quick. Come on. Maybe it's unplugged. 1 second. One, two. Okay, sorry about the sound. I have a broken wire down there I need to fix. So yeah, as I said there, let's just check this out again. So on this input board, we have these op amps, which are these JRC chips. Now these take the audio signal and they send it to the potentiometers for crossover and subsonic and low pass, high pass, gain, etc. And so they will have positive and negative 15 volts roughly on them for power, and then they have sine waves on some of the other pins. Now if one of these op amps is leaking or shorted, then what it'll be doing is it'll be sending DC signal to the input pin of the driver board here, and there is a capacitor in series with the audio wave to prevent DC from appearing on the pin. But if the DC spikes, then as the capacitor charges, it will send some DC to the audio input pin, and then the FETs will then have DC on them when you power the board up. So the fact that this amplifier only exhibits this problem when the audio input board is present, I would say that there is a problem on here with one of the audio input op amps. Now obviously, in order to diagnose this problem, I've got to plug this board back in order to make some readings on there with the scope. But if I plug the board in, then there's a high risk that some of the FETs are going to explode again, which I really don't want to happen. So rather than having to take the whole board apart and remove all the FETs, there is a trick that I can do to get this thing to power up, but without risking damage to the FETs. And what we can actually do, hopefully if I can, I'll zoom out a little bit on my zooming cam, and then I can maybe try and show you what I'm going to do exactly. So here on the output section, yeah, there we go. Let's just move this back a little bit. So yeah, here on the output section we obviously have the output FETs. Now I've got to remove these really in order to power the board up without damaging it due to this input board issue. But that's going to take some time. Now what I can do is I can actually lift one of the legs of the gate resistors going to the output FETs. I have to remove one of the legs of every single gate resistor on the output section. And so the MOSFETs will still get the rail voltage on the source. They'll have nothing on the drain. The gate of the MOSFET will still be grounded through this pull-down resistor that I'm not going to remove. See, we've got a gate resistor and a pull-down resistor. So no static or residual charge is going to build up on the gate and turn the FET on. But by lifting this gate resistor leg here, we disable the connection to the driver board over here. So the driver board has no connection to the FET. So as far as the driver board is concerned, there's no FETs in the board. So it should power up in exactly the same way as if we didn't have the FETs in. So what that will allow me to do is that will allow me to power the board up with the input board in, which obviously has a problem on it somewhere, and see what is happening to the low side drive, because the low side drive is turning the FETs on for a long time, which is causing the storage, the voltage and the power stored in the rail capacitors to go straight through the FETs, and that's why they exploded last night. So let's, without further ado then, let's check that this rail voltage is sunk down, and I'm going to start lifting the legs of some of these gate resistors. Cool. Let's turn my soldering iron on and get started with that. This is just saving time rather than having to take the whole board out again, because I've dismantled and reassembled this thing too many times now. So this is a nice little trick you can do. Good morning to Joe. If you just joined and wondering what the issue is with this Sundown, then just skip back a little bit in the live stream if you can. Scrub back a little bit. I played the ending of last night's stream just now for you guys. If you weren't with me live last night, you can see where we got to last night and what the issue was at the end of the evening, and then I explain what I'm going to be doing about it and what I think the problem is here. So you can just see I'm just lifting the legs of these gate resistors, that disables continuity to the driver board. I should probably put my head cam on for this, that would make it a lot better. I've used this trick many times when I have got issues with the drive that weren't really present when I was doing the main repair. Yeah, so by lifting the gate resistors here, we completely disable the MOSFET drive, so MOSFETs won't turn on and off with the drive, and it means we can look for problems with the drive circuit or the input circuit without risking blowing up any more FETs. Okay, that's all the ones on that side done. Let's go ahead and do this side. And then there's, I think there's one more over here. It's going to be slightly difficult to get at this one. So this will be the first time that I am actually seeing a inputs board issue on a Sundown. And it's very strange that we'd have an input board issue here. Because yeah, the amplifier blew because it had a short circuit on the speaker terminal, so I'm not too sure why that would cause damage to the input board, but here we are. Okay, so that is all of the gate resistors lifted, so we shouldn't have any continuity to the driver board on the FETs now. Yeah, cool, right. So let's just what we're going to do is going to turn the amplifier on and just double check that that is the case, that we don't have any continuity to the MOSFETs. And one way we can check that is we can actually, with the gate resistors lifted like this, if we put the multimeter onto diode beep setting, and then we probe either side of the output FETs, between the gate and the source, we should have absolutely no reading. It should just come up as a 1 or an overload on the multimeter. If there are any numbers on these FETs with the gate resistors lifted, then you have probably a shorted MOSFET or some other leaking going on somewhere that you need to look at. But with all the gate resistors lifted from the board, or also with the driver board out of the board, there should be no reading between gate and source on the FETs. So looking good here. Right, now for the fun part where we find out what the bloody hell is going on with this thing. So I'm going to plug this preamplifier board back in here. So it's going to slide back in to the main board, and now I can turn the amplifier on, and the problem can do whatever it wants to do, and it won't affect the output FETs because they're not connected to the drive. But that will allow us to see what the hell is going on here and why it's sending DC to the FETs. Okay, so let's get this thing powered up then. Let's monitor the rail first. There we go, amplifier's powered up, it's drawing 1.8 amps of course, and obviously we have nothing on the low side drain because there's no connection to the driver board. So now what I'm going to do is I'm going to actually turn my scope onto 2-channel mode. And what I'm going to do is I'm going to have a look at both of the low side drive waves as the amplifier turns on. So I'm going to take both my probes here, and I'm going to go ahead and probe. So let's have a look. Let's probe the low. So we need to probe this pad here, which is coming from the driver board, but obviously is not touching the gate resistor. Be very careful not to touch the gate resistor whilst you're touching this pad, otherwise it could short out this FET here. And I'm also going to probe the low side of the other side of the board as well. And if we look at the scope there, now these two things should both do exactly the same thing. The drive waves should appear at the same time and there shouldn't be any spiking going on. So I'm going to turn the thing on again. Okay, so you can see there that I might need to zoom in on my scope view. Let's just go to 10 US. Ah, there we go. There's the issue. Did you see that? Right, watch this. Watch this. This is the problem. This is what caused the amplifier to explode last night. Right? Now you see that glitching just before the wave comes into play. There's an up, down, and then the wave appears. That is what is causing us to have problems. Up, down, wave appears. See that? Up, down, wave appears. The waves should just appear freshly. And I can prove this. Okay, see that up, down, wave appears? I can prove this by now removing this preamplifier bit from the amplifier and probing the same points on the amplifier and I bet you that that won't happen anymore. There we go. See? That's what it should look like. Off, on. The waves should just rise into play nice and smooth like that. Okay, see that? Nice and easy. Right, however, the second we plug in the bloody preamplifier board, like this, and probe the same points on the board, now we have the glitching again. So the issue is on the preamp board. Very, very interesting stuff. So in order to find out what exactly the problem is then with this preamplifier board, I'm first of all going to go ahead and have a look at some of the voltages on these op amps. And actually what might be also a cool idea would be to compare the current draw of the amplifier with the board attached and with it not. So let's take a look on our screen here at the current rating from the amplifier's draw. So if I remove the preamplifier board, let's turn the amplifier on and see how much current it draws. So with 10.8 volts of input, we're sitting at 1.6 amps. 1.6, well, between 1.5 and 1.6 amps worth of idle current draw. Okay, now if we slide the preamplifier board in, if that current draw jumps up particularly higher, then there might be something that is getting a bit hot on this preamplifier board. So let's now turn it on again. Okay, the current draw is a touch higher, not significantly higher, not much higher that I'd say that anything is getting mad warm. I'm going to take my thermal imaging camera here and I'm just going to have a look whilst the amplifier is turned on. It's my doorbell. I'm just going to see if any of the op amps on here are heating up. It doesn't look like they are. If an op amp was dead shorted, it would be getting very, very hot. So I think that's going to be generally okay. Now, because the issue is with the preamplifier board, what's happening is it's probably sending some DC spike. I might just need to get that doorbell. Just bear with me one moment, actually. I think I'm the only person in the house. Bear with me one moment. Right, yes, apologies. Where was I? So, preamplifier board, nothing's getting hot on there. So, what I'm going to do now is take the oscilloscope probe and I'm going to start probing the audio input pin of the driver board. Because I imagine that there's going to be a spike on that pin, which is causing DC to happen on the FETs. So, let's go ahead and check that now. Maybe I'll do the head cam again. So if I can't remember on this board which pin is the audio input pin, but I imagine it will be the one that has the big spike on it as we turn the board on. So let's zoom in on the scope to 5 volt divide. And let's start powering the board up again and seeing, you can see on the screen there on the scope. I'm just going to enlarge the scope screen a bit, I think, actually. So you can see that a little clearer. There we go, that's a bit better, isn't it? So you can see the scope a little bit better now. Okay, let's try and power it on. Okay, so this pin here is rising to 12 volts. So that might be what it's meant to do. So on this middle section of pins here, this is where all the low voltages are. And we should have some supply voltages, so it should be plus and minus a few voltages. So let's have a look. So this is the oscillator output. Okay, this is the oscillator outputs of the driver card. So if I switch it on again, you can see there that the spike is present on the oscillator output. So it's not the drive ICs, it's being sent before the drive ICs. So let's have a look at that. So we've got negative 5 volts, that's fine, that's meant to be there. This one is... not too sure what this one is. This one might be ground or something. With the amplifier turned off, it sits at 1 volt. With the amplifier turned on, it sits at ground. There might be something to do with protection, perhaps. Let's go to this next pin. Aha! So there's a big wobbly spike on that, did you see? So as the amplifier turns on, that does the same thing as what we see on the output FETs. There's a big boof on that. Watch on the scope. This pin here, that is what causes DC on the FETs there. So I wonder whether that's the audio input pin. It might be. Let's go along to this next one. So this next pin is the positive 5 volts. That's fine. Next pin along is probably going to be positive 12 volts. That's probably fine. And this last pin, I imagine, is ground. And that is staying at ground. So yeah, the last pin is ground there. Okay, so I imagine that this one that has the big budoof on it, not this one. Where's it gone? Well, one of these pins has the big wobbly on it. There we go, this one. I imagine that one is most likely the audio input pin, I think. So in order to confirm that, we can actually have a look at the op amps here, and we can see where that is sort of coming from. So if we take a look, I'm going to start probing some of these op amps. So on these op amps, we should have positive and negative voltage supply to the op amp. And then on all the other pins, we shouldn't have any DC whatsoever. If there's any DC on any of the other pins, then that op amp is most likely dodgy. So we're going to have a look at the supply voltages for this op amp over here. This is a JRC. This is a 074D, which is very similar to the TL74074C. So we've got 12 volt supply on that one there. And let's find the negative volt supply. There we go, negative 13, that's fine. And there isn't any DC anywhere else on that op amp, so I think that's going to be okay. There is a bit of a bump actually. As we turn the op amps on, there is a bit of a bump on them. Alright, let's check some of these other op amps over here. Ah, there it is. Look, see, there's a pretty big bump on this one as we turn it on. Yeah, look, there's a pretty big ass bump on this op amp as we go to turn it on. There it is. Does it do the same thing in slave mode? It does. So it's not slave master switch related. There's a big bump there when that turns on. Okay, I'm going to check for DC anywhere on any of these. So I'm just going to go ahead and check every single pin. You guys tell me if you see any DC that isn't plus minus 12 volts on any of these pins. Thank you massively to Super OB96 for the comment there. Very kind of you. Okay, that's our plus 12. Minus 12. Okay, nothing there. So that's our negative 12. There's a bit of DC on this one. Only 0.4 volts worth. But it's still there, and there's still a bump on this as we turn it on over here. Plus 12. There's a bit of DC on this one. It's very small, but it's still there. Aha! There it is, bruv. There it is, my man. Holy fucking shit. Right, look at this. Look at this bad boy. So this op amp here, this JRC, this is a 4556AD, okay? Now this has on it the negative 13 volts worth of supply voltage. It has the positive 12 volts worth of supply voltage, and on the other pins it should have nothing. However, pin number 3 has 2.6 volts DC, pin number 2 has 2.6 volts worth of DC, pin number 1 has 2.6 volts, 2.7, and the other pins have negative 2.6, so there is some DC there that should not be there. Wow. Okay, so it could not be the IC. There could be a leaking capacitor that's causing that to happen. But our first port of call then is to remove this op amp and see whether the DC goes away on its pins. Okay, making progress. How weird that a tiny little op amp on the preamplifier board can cause the FETs to explode in such a violent manner. So has anybody just joined me? Please let me know in the live chat. If anyone's recently joined me and they don't know why I'm repairing this or what the issue was, then let me know, because this is following on from my live stream last night that we did at 3 AM in the morning here in the UK. I repaired this amplifier, spent 4 hours repairing everything. It was a complete rebuild. It needed a new power supply FETs, power supply drive circuit, output section drive circuit, output FETs, and we made a good repair. But as soon as we put the board back in the case with the preamp board attached, it blew the FETs up, and I was like, what the fuck? I couldn't believe it after all that time repairing it. And when I've gone to then re-repair it again today, it works beautifully fine without the preamp board attached. But then as soon as I slid it back in the case, there was some issues again, and it's sending negative DC voltage to the speaker terminals. So I was like, right, the issue must be on the preamp board. So this is what we're looking at now. We've just diagnosed that actually, yeah, one of these op amps does appear to be leaking and sending some DC to the to the board. So what I'm going to do now is, and also if you missed out last night, the explosion, let me see if I can replay that. So for anyone that's just joined us, let's have a look at the explosion again from last night, and which is why I'm doing this repair here just now. Whoa! So there we go, that's what happened last night. As soon as that is what this tiny little op amp actually is caused. This tiny op amp, potentially, if this is what is at fault, made that massive explosion on the FETs just because it's leaking possibly some DC. So let's get this thing out of here and then go from there, and hopefully we'll make some progress. Let's have a look at what's going on in the live chat. It's really nice actually. When I do live streams at different times of day, I get a different audience. So it's nice seeing some different names, because often the live streams I do are in the evenings, and I catch a lot of the American viewers. But when I do the live streams during the day, I get a lot of European viewers and stuff. So yeah, good afternoon from Spain. Buenos tardes to Bellarama. I hope you are good. Start removing this op amp here. What else have we got in the live chat? I don't mean to interrupt, but I think you'd find something interesting. So the G series Helix amplifiers use Chinese boards, the same used in the older Hyphonics amps, just like Phoenix Gold. God damn! Yeah, too many brands are running on their old reputation based on their brand name. They've probably been bought out by some big fat businessman who drives a Mercedes, and all he's interested in is about making profits. So he can sell really cheaply badly made amplifiers for a lot of money, because people still think that they're worth a lot of money because they have the brand name associated with them from the good old days when they actually were good amplifiers. But now they're just the same old crap, and but they can still charge a fortune for them because people don't know what's inside the amps. People don't understand what's inside the amps, and so they just buy the brand name. And this is one of the reasons that I make these sorts of videos, is to get more people in tune with what is inside their amplifiers and why some amplifiers are worth more than others, and what's a good amplifier to actually put your money in. And so yeah, and also just to gain, even if you're not looking to do amplifier repair, just to gain familiarity with the different board layouts, so you can actually have a look at an amplifier's guts, and rather than just looking at it and thinking, oh, that looks pretty big, like, oh yeah, there's lots of components in there, rather than just thinking the generic crap like that, you can actually think, look at it and say, ah, right, okay, that's a generic IRS-21844S architecture output section. That, you know, it's nothing special. They've not designed that. Or, oh damn, that's a really old school discrete class D based on the AKG and DKG transistors. Why the hell is that costing so much? As in the case of the Phoenix Gold amplifiers. So it's really, really good to be able to look at the amplifier guts and recognize what you're seeing. Okay, so we've removed that op amp that had the DC on it where it shouldn't have been. Just gonna make sure I've made no solder bridges under here. Okay, so that's slid back in there. So let's pull this forward again, and I wonder now whether that DC on those pins has disappeared. If it has disappeared, then it's the op amp that is faulty. If it's not disappeared, then it is something else in the preamp board that's causing the problem. Sam, was it just a few FETs that popped? The only ones that were getting the DC, listening from work, says Josh Hansen. When it went pop, I lost about 3 or 4 FETs, and they were all on one side of the board. Yeah, basically all of the FETs were getting the DC, because the DC was coming into the audio input pin. So all the FETs were trying to do the DC, but it would have been probably the low side FETs that would have been doing the DC, which then would have powered the high side FETs into oblivion. So the FET that exploded was actually a high side FET. That was the one that went bang, proper bad. There were a couple others that had exploded, but there was one other that exploded, and there was a few others that were short. So yeah, it did a fair bit of damage across the board. Right, now let's get this and have a look. So we get our head cam back on active, and so these pins here had some DC voltage on them. So let's see whether that's gone away or whether it's still there. So we have our negative 14 volts and positive 13.3 volts. Ah, so we still have some DC. So the DC is on pad number 3 there. Okay, so that's cool. That's isolated it. So it's a good job that we did remove that. That's our IC there, because it is actually isolated the problem more. So the DC is on pad number 3 of this op amp location. So the op amp is probably fine. So that means that the DC is coming in from somewhere else. So let's have a look on either side of this capacitor. We have the DC on one side, but nothing on the other side. That's probably fine. So what we're looking for is we're just looking to find that DC somewhere else on the board. And the components that are most likely to die are most often going to be semiconductor components like diodes and transistors here. So I'm just going to go ahead and probe some of these small diodes first. To see whether there is any DC on these. Now, interestingly, you see these blue capacitors here. These also have a tendency to fail and to leak, and that could be what's causing the problem here. Yeah, I need to probably turn the amplifier off, and I need to check for continuity and find out exactly where this DC is coming from. I think I found it. There's another bit there. We've got 15 volts on there. It's probably not coming from that. 15 volts in there. Okay, so let's see, where else could it be coming from? It's not on any of the other op amps. It's only over here on this section around here. Okay, so I need to find out then what this resistor. See this resistor here? R283. This is the one that has the DC on it that shouldn't be there, and it's on the other side of it as well. So we've got 2.7 volts on the other side and 2.6 volts on one side. So it's coming from this side of the resistor. So I need to go ahead and take this board out again now and check to see where exactly that trace goes. So if we put our finger on that there, we can flip it over and have a look. Okay, looks like that is coming from, so we got it on the capacitor, but it's not the other side of the capacitor. It goes over to this resistor here, R281, I think. So R281, let me just put that back in the board and follow R281, see if the DC is still there. The traces are quite hard to see, but I want to actually follow the DC, not just the trace. I want to see where the DC goes as well. So yeah, the DC comes pretty much straight away there, and the DC is even present actually with the amplifier turned off. That's really curious. So let's go back and let's have a look. 14.4, 3.3. So we've got 14.4 volts on this R281. I wonder if that should not be there, perhaps. I wonder if these shouldn't have DC on them actually. Yeah, that's really interesting. So we've got small bit of voltage there. Okay. So let's use our multimeter and let's check that. Let's trace it back. So let's take our multimeter on diode continuity setting. Right, so the resistor that has the DC on it is this one here over this side of the board, which is pad number 3. Okay, so let's put our multimeter on pad number 3 here, and then we're going to go ahead. So there's continuity there. And then this is the other side of the resistor. Now, what else is this resistor connected to? So we've got it connected to this resistor over here. What else is it connected to on the board? It's also connected to this resistor, and this appears to perhaps go to ground. So it could be coming from, I wouldn't have thought it would come from ground. So it's probably not that, it's probably coming from over here. This resistor then goes to this one, and this resistor then goes to there. So that is, there was like 15 volts on this resistor here, and it's probably being dropped down. So if we follow this resistor's trace, this is R280, if we follow this trace, where does that go? That goes over here to this one over here, which then goes over here, which then goes over here to this resistors over here. And it also trails off, it also goes elsewhere. It goes to a lot of places actually by the looks of it. That's interesting. The issue might actually be coming from the amplifier board itself rather than from the drive board, because I've just noticed that there's some continuity there between that resistor and a pin on the actual amplifier board itself. Now, it would make more sense if the issue was coming from the amplifier board itself, because the amplifier is the thing that had the failure in the first place. So that's interesting. I wonder whether the issue might be coming from the actual amplifier board itself rather than on the preamp board. So curious. Right, what I'm going to do is I'm going to actually probe some of these pins on the amplifier's headers and see what we've got. Now, I don't have a schematic, so I don't know which ones of these are which, but I should have this thing should only be feeding plus minus 15 volts roughly to the drive ICs on this preamp board. If there's any other DC anywhere, then that's probably a problem. So let's fire the amplifier up once more, let the relay click in, and let's start probing some of these pins. So let's find the pin that has the, okay, so this one has some DC on it. Wow, this one has 104 volts. Is that the positive rail? Yes. Okay, right, so this one has positive rail on it for some reason. Where's it gone? There we go. This one has positive rail on it. Okay, this next one has 2 volts on it. No, it doesn't. It has nothing on it. It's just me. This one has nothing. So we have positive rel on this pin. Nothing. 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 Okay, so it doesn't look like there's anything on any of the rest of these. So on this connector block, we've got positive rail on this middle pin there. Okay, interesting. I wonder if that shouldn't be there. Let's go along to this other side. This other set of pins. We've got negative 14 volts, which is correct. That's correct for the op amps. We've got positive 14 volts, so that's our two power supply voltages for the op amps. So why the hell do we have rail voltage going to the preamp board, I wonder? This center pin is nothing. This pin is nothing. This pin is nothing. Let's drop down. That pin is nothing. That pin is nothing. Nothing. And we have positive 14 volts again. Negative 14 volts again. Okay, so the only one that seems weird is this pin here, which has 104 volts sitting on it. So annoyingly, I can't view the trace on this without taking the whole board out again. But I'm wondering actually whether the voltage regulators here have been damaged, and that might be sending quite a high voltage there. So if I remove the voltage regulators here, voltage regulators are things that can get damaged when the amplifier goes down in quite a bad way. So let's remove the heatsink for that. And I'm going to actually pull these regulators. So here we have a KA7812. So we should have 12 volts on either side of these. So if I turn the amplifier on again, I'm just going to use my thermal imager and just see whether they're getting really, really hot or not. Okay, they're not getting hot, they're not actually doing anything. Usually the KA7812s warm up a little bit on idle. So let's take our oscilloscope probe and let's have a look and see what is on these 7812s, because we should have a 12 volt reference there. So if I can't remember which of these is the input. So we have negative 90, negative 103, and negative 91. Okay, so yeah, there is a 12 volts on this one. Negative 91, 103, negative 90. Okay, so it's not coming from the voltage regulators, because on it's the pin where we have positive rail is this one here. And I really don't think that should be there, because that is then sending positive rail. If positive rail is on this pin, that then sends positive rail to this resistor here, which then sends it to this resistor, which then sends it to this op amp. But that doesn't make any sense. It shouldn't. Why would it be doing that? So I need to wait for the amplifier. I need to wait for the amplifier's rail voltages to sink back down to 0. And I'm going to use my multimeter. I'm going to check for continuity and find out where that rail voltage is coming from. And it may be the case that I need to take the amplifier out of the fucking heatsink again. And if that's the case, then fine, we'll do that. Another thing I could try is I could try temporarily disabling. Actually, that's something interesting that I'll do. Right, let's, just while the amplifier is still powered up, let's try temporarily disabling this rail voltage pin here. So what I'm going to do is I'm actually going to bend this pin upwards, right? And that means that it won't actually slide into the header. See that? So all the others are going to slide in. That one is going to stay up and out, so it's not going to actually make a connection to the board. Now let's actually put this op amp back in. This op amp that we removed, let's solder that back in, because that's probably fine. The DC voltage that was there is not as a result of the op amp leaking, I don't think. Let's solder this back in, and then I'm going to see whether not having the rail voltage there makes any difference to the DC voltage on this preamp board. Question, how can I check amperage on a multimeter? Well, most multimeters will only pass a small amount of current. Usually multimeters can pass 10 amps and measure 10 amps. So you can't measure the current draw from your amplifier with a multimeter because the multimeter will likely explode because the amplifier will draw in excess of 10 amps. However, if you are using a current limited power supply, let's say that you are doing some amplifier repairs and you are using a small, let's say a 5 or 6 or 7 amp power supply to do your amplifier repairs, you can then run the power wire through the multimeter and you'll be able to read the current drawn from the amplifier, because the amplifier will never be able to draw in excess of 10 amps because the power supply can only provide 6 or 7 or whatever it is. So you can use a multimeter to do that. Right, okay, cool. So now that's in there, let's power this back up and see whether the DC voltage is still there, whether it's gone away. So it was on pin number 3 here. Let's go ahead and fire up. Okay, yeah, it's gone away. So the DC voltage is no longer there anymore. So I believe that the issue is that we have 104 volts coming in on this pin for some really strange reason. That's really weird. Why would that be there? I think I'm going to have to go ahead and take the amplifier out of the heatsink again and have a look at the bottom of the board, because I can't see where this trace goes. I mean, obviously it's connected to positive rail, so that's not really very helpful to me. Oh, this is so annoying. I've put this thing together and taken it apart so many goddamn times now. I really don't want to take it out of the heatsink again, but I think I'm going to have to. Yeah. Under no circumstance should the amplifier be sending 104 volts of positive rail to the preamp board. There's absolutely no need for that whatsoever. And that may have damaged some components on the preamp board. Okay, so we've got R280 here. That looks a little bit burnt. So we have to check the reading on that, make sure that that's fine. Right, I'm just going to wait for the amplifier's voltage to sink down. I'm just going to go and get a soft drink, so bear with me, I'll be back in 1 sec. Okay, lovely stuff. Bit of apple and raspberry. So we're just waiting for the rail voltage to sink back down. And once the rail voltage is sunk back down, I will remove this thing from the heatsink again. For the 4th time now! The 4th time I'm removing this from the heatsink. I should probably just leave it out the heatsink, shouldn't I, for the time being. Good afternoon from Kenya. Afternoon! Afternoon to Kenya. How's it going, Phil Don? Good to have you on board. So, once again, just because it's really fun, for those of you who are recently joined, this amplifier caused me the following issues last night. Let me show you the video again. So last night on live stream we had the following problems with the amplifier. fixed yet. So yeah, whoa! So yeah, that's what happened last night. The FET exploded after we reassembled the amplifier, and it appears that we have located the issue. The problem is that there is 104 volts worth of positive rail voltage going into the amplifier's preamp board. So we're just waiting for the rail voltage to sink down. I might actually use my tweezers and just short out the rectifier here, just so that I can hurry on up with this repair. There we go, right. Yeah, I'm going to start dismantling this again now. What was Scott Maltby's question? I need to scroll up in the live chat. Sorry, I've not been paying too much attention to the live chat because I just want to get this done. Bevis, hey bro, got an amp with a blown MUR 1620 diode. Can't find local. Is there a better replacement you can replace with? I would just check out on whatever website you buy your electronic components from. RS Components, Mouser, etc. Just make sure you get yourself a ultra fast recovery diode that is 200 volts, which is the 20, and the I think it's the 16 part is the current handling, so it's 16 amps. So just make sure that you get one with the same specifications, and it'll be fine. I can't remember the exact model number of the ones. I have used some others to replace with, but I can't remember the exact model at this point in time. Sam, I know this is stupid to ask you, but what are you using for ground reference? So interestingly, the setup that I have, my oscilloscope isn't floated from the mains ground. And so my power supply, my bench power supply, is the ground output is floated from the mains ground. So what I do is I'm just looped round, so I've connected my power supplies output ground, the negative voltage output, to the mains ground connector, which then the oscilloscope can use as a ground reference. So I don't actually need to have the oscilloscope connected to a ground reference anywhere, because it is finding the negative of the power supply through the mains ground. And I've been using it like that for over a year, and it's been great. So if this is just a solder bridge that's caused this issue, I'm gonna go nuts. I was very tired last night when I was doing this repair, so it could very well just be a solder bridge on the underside of the board. It's sending positive rail to there. This amp is making me work every penny. I'm here from last night and now I'm at work 8 AM and tuning in again. Oh well, thank you very much for your dedication. Yeah, this amp is really definitely cutting my work out for me. I didn't think this amp would be such a headache, to be honest, but fortunately we are actually making progress and we're finding the problems. It's, you know, it's not giving us too many headaches in terms of like weird issues. Like the like Giant's Steg is giving me more headaches than this because well, the issue that it's making doesn't make sense to me, whereas this issue does make sense to me, so that's fine. Personally, I'd be happy if it was a solder bridge, because then at least you'll have found the problem. Yeah, I would quite like it to be a solder bridge, but I'll also be quite pissed off with myself if it is a solder bridge, because I wasted a bunch of FETs and a load of time just from being a solder bridge. Right, so let's have a look then. Let's remove this bit of foam, because it's better without the foam when we're doing it on the board. So, let's see then. You know what? I think it is a solder bridge. Right, the reason I think it's a solder bridge, okay, this is quite a common problem. This is a really shit board design. I hate boards that have these traces designed where this is, right? So if we take a look, right, the pin that was causing us issues that has positive rail voltage on it is in fact, it's the one at the back in the middle, so it's, right, it's, oh, what the fuck, no, it is meant to be positive rail. What the fuck? But there is a solder bridge here. Oh no, there is meant to be, no, that's all connected to the same shit. What the fuck? Why would it be sending positive rail to the driver board? That is where that trace goes. No audio. No audio? Oh, there is audio. No, I've obviously scrolled up on my... Yeah, look. This trace here goes to the positive rail. Oh, man. Okay, now I'm starting to dislike this, because now it doesn't make any sense. Okay. I'm going to power up again. I'm just going to watch what goes on because I'm seriously confused now. Right, so the issue is still present. Okay. Right, let's compare. Let's compare the DC. Let's compare the DC on that pin to the glitchiness of the drive wave. So I'm going to turn probe 2 on here. And I'm going to probe using probe 2 and probe the low side drive, which is giving us the weird glitchiness. And on this probe, I'm going to probe the pin with the DC on it. I'm going to see whether the two correlate with each other. Not really. But the bumping on the audio wave there does correlate to that starting. See, now if we were able to mute the drivers before that started, then we could prevent that from happening. So I wonder whether the muting transistor has actually failed. That could be something else that has happened. So the muting transistor is just in the center of the board here. There's a tiny little transistor, which is just this little thing here, and this is called the muting transistor. And this will disable the drive ICs so that they don't send their the drive to the FETs. It disables the drive ICs so they don't activate. And I think that there should possibly be a delay on when the drive ICs are being told to turn on. And I wonder whether that delay is supposed to stop that bump of audio getting to the drive by delaying the turn on of the chips until that bump has finished. So it could be a problem with the... I mean, that I'm still not convinced that should be there, you know. Hello to Seth. Good afternoon, buddy. Thank you for joining the stream once again. Seth is a regular viewer, a very valued viewer to me. Okay, right, so it hasn't got anything to do with the rail voltage, so I was wrong about the rail voltage on that pin. It is supposed to be there, and it's not what's causing the problem. Okay. So by disabling the rail voltage on that pin, it doesn't cause the bumping of the audio to go away. It's still there, so that is not the problem here. So I either need to stop the bumping of the audio wave as the amplifier turns on, or I need to lengthen the delay period in which the amplifier comes on. So if we take a look at our muting transistor in here, I'm just going to probe the muting transistor. That's so annoying that it does that. Fucking live chat. All right. So I probe the muting transistor just here. I'm going to see what this does. Okay, so there's a constant, what's what we got? Let's have a look. Turn that off, go up to 50 volts. Okay, so this pin is just following the negative rail by the looks of things. That's fine. Pin number 2 here. Pin number 2 is doing some crazy shit. What the hell? And pin number 3 is following the negative rail. What the fuck? Let's see whether probing that with the drive active actually changes the drive. So if we use probe number 1, I'm going to probe the output of the driver, so we can see that there should be drive waves there. Let's see. Yeah, so let's probe the drive. So you can see the drive waves there on the screen. Now if I probe the muting transistor, does probing the muting transistor turn the drive off? No, it doesn't, but it still looks weird as fuck. Okay, weird. Maybe I could try removing the muting transistor and see whether that makes a difference. This is the same problem I'm having on an Incriminator audio I asked you about a month or so ago. I still haven't repaired it. The preamp board has 4 of the 218. No, this is the driver board. So the driver board has 4 of the 21844S. Yes, that's correct. One thing that's got me curious is to see actually whether the preamp board is passing any audio. So if there's a problem in the preamp board, then maybe I can find out where the issue is by seeing whether the preamp board actually passes any audio. So let's take some RCAs and plug our phone in, and let's see whether it passes any audio. Yeah, I agree with Tom. It looks like a cap that's filling and dumping repeatedly. Let's get the function generator on the phone. Sine wave. Let's play 47 Hertz. Hit start. So we're looking for the sine wave to be coming in just about here. So if I turn my scope settings to be able to view the sine wave nicely, you can see we've got the sine wave coming in there. Okay, so let's now probe the audio input pin of the driver board and see whether the audio ends up there. Yeah, so the audio does end up there eventually. I need to turn the gain down though because it is a clipped signal at the moment. There we go. So when there's signal playing, what happens to the drive? Does it actually look bad or not? Does the drive do that jumping thing when there's actually an audio signal there? Looks like it does a little bit. It's hard to tell. Maybe I need to zoom in. Yeah, the FETs actually are turning on. It's telling the FETs to turn on a bit too quickly there. It bounces up a little bit quick there, so there's still, I think, a problem. Yeah, it still does that weird bouncing thing. Okay. Okay, so an interesting thing to do would be to actually remove the pin for the audio input wave, and that will confirm whether it's coming from the audio input pin that is causing this bump. So if I find out where the audio input is for the driver board on here, it must be one of these bottom ones. Ah, there it is. It's this one here. Okay, so if I go ahead and if I remove, so let's pull this preamp board out. So this pin on the end here is the audio output from the preamp board, and it goes to the driver board. So if I just lift that one, so I disconnect that from the driver board, that, if I'm thinking correctly, should stop the glitching problems on the drive if it is actually coming from the audio wave. Yeah, it's better. Still not perfect though, I don't think. Let's just see. So it goes, it still pops up a little bit first. Yeah, I don't think it should pop up a little bit first like that. I think it should just build the wave straight away. If we try it once more with the preamp board fully removed. See, that's what it should do. The wave should just build really, really cleanly like that, with just the pulses building. Whereas when we put the audio board in, like this, we get this little bump first, and then it builds. See? So with the preamp board attached, there's I'm not sure how the refresh rate of my camera isn't necessarily going to make this out too well, but with the preamp board attached, there's a bump and then the waves build. Whereas if I remove it, then the waves build just very, very cleanly with no kind of bump. So that's something to look for, I think. So if I probe the audio pin now, so the audio pin shouldn't have any connection. It's got 1 volt on it because nothing connected to it. So if I turn the amplifier on, okay, there's no bump on the audio pin, okay, because it's obviously I've got the whole board out. If I put the rest of the board back in but still leave the audio pin lifted, now what do we have on the audio wave pin? It's the same. Okay, so it was obviously something else that's causing that. Whoa! Ah, Jesus Christ. I blew something up. That was my fault. But I wonder what... I can't actually see what I blew up just then. I think... Actually, I don't think I blew anything up. I think what I just did is I think I just grounded... I think, yeah, I grounded 100 volts to ground, So I don't think I actually blew anything up just then. This is this is the risky business with these headers, right? Because obviously I'm sliding this headers in backwards and forwards like this, and what I've done then is I've accidentally touched the there. Here we go. I touched the ground lead here. I touched that to the positive rail. So what I just did then, nothing actually blew up. I just grounded 104 volts with no resistance between it, and that made my ears hurt. That was a loud bang. So actually I don't think that didn't actually damage anything on the board. I don't think. I can probably just go ahead and turn the amplifier back on and it's probably fine. Let's see. Okay, so I did damage something. I can see here that something is getting smoking hot, and I think I probably blew up one of the KA7812s because we've no longer got any voltage going to the driver board. So if I check here with my my thermal imaging camera here, we've got 100 degrees on the 7812s. So by touching that to ground, I blew up the KA7812s. That's not a problem. They're pretty cheap. Silly mistake. But it's always risky business when you're probing around and swapping things around with 100 volts DC sitting on the board. So I do just need to go ahead and replace those KA7812s now. I think I might have 2 spare here. There we go, right, there's one, KA7812. And here's another. Right, okay, cool. So I've got 2 spare 7812s. Let's just change those really quick, seeing as we blew them up. I'm lucky actually that I hopefully haven't damaged my mobile phone, because my mobile phone was obviously plugged into the preamp board, and that probably will have sent 104 volt spike to my mobile phone, to the mobile phone ground. So maybe I should check whether the headphone output still works on this. I don't think I've got any headphones here. I can use my scope though, I think, to check that. Yep, the headphone jack still works, so we haven't damaged my phone. That's good. Oh, starting to rain outside. I need to move something from here. There's thunderstorms outside at the moment now. It's pretty cool. I left something outside and it was getting wet, so. Wow. I'm not sure if you guys, yeah, I'm not sure if you guys will be able to make this out, okay, but that shorting that out there completely obliterated this track. So this is a bad mistake by me, and I'm going to have to obviously repair that. But you see this trace that was connecting the positive rail to this pin, well, this trace has obviously acted like a fuse. So this trace has completely exploded like a light bulb filament to this pin because I've grounded it. So we're going to have to run a small piece of wire to replace that trace there. Bellamar, yes, that's basically the loud pop that you guys heard was the big spark that's caused by high voltage and high current. So we had the capacitor bank discharging. So we had 104 volts DC, and that shorted directly to ground, and that's what the big spark and bang was. There we go, that's the trace repaired, so just so you guys can see that. Just ran a small bit of wire. I've just followed the path of the old trace, so that's fine. So I wasn't any closer to figuring out what's wrong with this this thing. Oh yeah, one thing I was going to do is I was going to remove the muting transistor and just measure that and make sure the muting transistor wasn't dead, because that could be causing issues like this if the muting transistor is dead. But I imagine it's probably fine. Thank you for the compliment, Tom. Okay, so this is the very small muting transistor here. Camera won't focus. So I'm going to put that into my transistor tester and we're going to see whether that measures what it is supposed to. If you run that wire, you will turn that amp into a PC. What do you mean? Oh, is that a Lewis Rossman quote? I'm not familiar with that quote. Oh, because it then becomes better build quality than a Mac, so we're turning it into a PC. Very funny. Okay, so this transistor appears to be okay. Well, it's difficult. I'm not too sure. Now, when a transistor like this, an NPN, when it starts leaking or going bad, the HFE will go very, very high, which is the current gain of the transistor. So the HFE of this one is up at 319, and that seems quite high. So I don't know whether that might be causing us some problems here. What I am interested... oh yes, I need to change the 7812s as well. That was what I originally came here to do. Change the 7812s because I fucked those up big time. Ampere audio, the reliability seems to be a bit better. I'm a massive fan of Ampere audio because I've never actually seen Ampere audio brand amplifier, but it's exact same stuff as LW audio, the stuff that I sell. It's literally the exact same boards, same everything. And the LW audio stuff is fantastically reliable, really good quality boards. So yes, I'm a big fan of Ampere audio, and I would even put it as more reliable than Sundown for sure. Bevis, do you have any kind of social media we can follow you on? Like yes and no. I do have a Bevis Facebook page, but I rarely put any updates on there at all. So apologies for that. I don't really do that. Generally, the only social media you can really follow me on is my YouTube channel. If I have anything interesting to show you guys, it'll be on my YouTube channel. I don't generally do updates on any other social media platforms as such. Okay, so that's the new 7812s fitted. So I'm just gonna, before we go any further, I'm just gonna power the board up and make sure that none of the drive circuit got damaged. See, this is the problem when you have a big spark like that, you can actually kill so many things on the board. So I really hope that we didn't kill any of the drive circuit or anything like that. So let's just go and check that out first. Power the board up, make sure we haven't killed anything else. Did you receive the 2 B2 monos? I think so. There's a few boxes that I haven't opened yet that have come from delivery. So yeah, apologies. I haven't actually opened all my boxes yet. So I think they probably have arrived, but I just haven't checked the box yet. Ah, shit. So there's no drive wave anymore. That's not good. So what have I killed? It could have been a couple of these very small inductors actually for the power line. Could have killed those. Actually, no. There's probably no drives. There's probably no drive wave because I removed the muting transistor, didn't I? Yeah, I forgot about that. So let's power the board up again. Let's make sure the 7812s don't get really hot. Put my head cam back on so you can see what I'm doing. I was worried then that we killed something else, but I just remembered I removed the muting transistor, so that could be the reason. Okay, yeah, cool. So the 7812s aren't getting hot anymore, so that's good. So that's that bit fixed. And it's probably the fact that we haven't got the muting transistor in, which is why the amplifier doesn't have any switching waves. So if I go ahead and probe the that area of the muting transistor now, does it do that same weird thing it was doing earlier? So we should have negative rail on one side, 101, negative rail on the other side, and in the middle, yeah, we have this kind of weird. So maybe the muting transistor is to blame here. So the muting transistor is an NPN. So I could try replacing the muting transistor with a BD139 and that might cause some different things. So ECB 123, so let's take a BD139 from in here. See if we can find one. There we go, there's one. Just spin the legs back around because they've been twisted from some other test I was doing. What does Ampere do differently on the boards to make them very reliable? I don't know, it's just a different circuit design. It's just a slightly different board layout. I'm not entirely sure that on the exact details, the reasons why they're more reliable, I don't really know. But they just seem to work like that. You can abuse the hell out of them and they just seem to be really, really good. That's a much lower HFE and it is ECB123. I'm just going to double check that on the muting transistor from the board itself. ECB123. Where did I put the muting transistor? Where the hell did I just put the original one? Can anybody remember where my hand went to put it down? Ah, it's here, it's here. Found it, found it. ECB 123, pin out. ECB 123. Okay, cool. So the HFE is quite a lot lower on this one, so I wonder whether this is going to make any difference whatsoever to how this amplifier behaves. Should probably wait for the rail voltage to sink back down fully first. We've got 19 volts still sitting on there. Have you ever repaired an Audison VRX404XR? No, it doesn't ring a bell, that one, unfortunately. Sorry, bud. Yeah, most of the MOSFETs on Rockford amplifiers, I have also noticed myself, do seem to run pretty hot. I agree. Okay, so with our new muting transistor in, let's see whether we have the drive waves present like we had before. I really hope that we do. Ah shit, still no drive waves. So that means the driver board is probably not getting any power. So I probably did kill some of these small inductors here with that big flash spark. Let's check, see. 5, that's correct. That's correct. Either that or this muting transistor doesn't work. Okay, that's really strange. That seems fine. So maybe that muting transistor doesn't work. Either that or we have killed something on the driver board itself. We've got 4 volts DC on the output of the oscillator pin. The drive ICs are warming up, which means they're getting power. So it's possible that we're just not getting any mid power here. So we've got 17 volts there, 15 volts there, ground, negative 18, negative 18. So it's possible the driver board is not getting any voltage on this, plus minus 5 volts, plus 15, plus 4, minus 4, minus 4, plus 4, minus 4, minus 4, plus 4. I don't remember there being 2 minus and plus 4s. That's weird. Okay. So yeah, that's not activating. The drive IC is unactivating still. It could be my dodgy, it could be my replacement muting transistor is no good. So maybe I'll try and put the original muting transistor back in. The thermal imaging camera I have is as follows. It's just this K-Moon from Amazon. I wouldn't necessarily recommend it. It doesn't seem to work that well. It's pretty... You can't really pinpoint exactly what's getting hot. You can just see a rough area of what's getting hot. It's probably not the best one you can buy. This is really annoying. I hate going backwards like this. Okay, I'm going to put the original muting transistor back in because I don't trust necessarily whether the one I fitted is doing its job properly, and that could be why we have no drive. At the moment I'm just confused why we don't have any drive still, so after that small hiccup with the pins. Morning from Michigan, morning. Right, original muting transistor back in. Please give me the drive wave that we had before. Please, please, please. Please, please, please. Pressing the wrong pedal, that's why. Oh no. No, no, no. Ah, oh, fuck. Still no fucking drive waves. Shit. That means we killed something else. Something probably killed a bunch of shit on the driver board, for fuck's sake. Luckily I have some spare driver boards for this amplifier here, so I can just populate these. I've got one with FAN on it already. One of the drive ICs is reaching 76 degrees. The drive ICs are probably dead because they're reaching like lots and lots of degrees. Usually if the drive IC is dead though, it sends DC. The driver boards are very generic and common in this, yeah. I got loads of spares of this. So I need to go ahead and probably swap out the driver board. So I've got another spare one here that probably just needs a bit of a clean. Hi Speaker Freak, hello. Okay, driver board is almost out. I think there's one pin here that I've missed. There we go. Okay, so driver board is out once again. And yeah. So let's first of all, I've got a driver board here that appears to have everything populated on it. I can't see anything missing. So I'm actually just going to drop this in first of all straight away and just see whether this other driver board works without needing any repairs on it, rather than having to swap out the ICs again. So I'm literally just going to slide that in there. I'm going to power the board up like this, just to see whether that driver board is working. I can't remember if that one is working or not. So. This driver board seems to have something leaking on it that's not quite perfect. I think it seems to have a dead IC on one side, because we have some DC voltage on this IC over here. Some negative DC voltage, negative 8 volts down there. That shouldn't be there. Okay, yeah, so this, or maybe not, maybe if it's just if I do that properly. Okay, let's see. Okay, so this driver board is bumping into operation like this. Okay, looks good. So this driver board seems to work. That's good. It means I can just do a straight swap. Yeah, cool. So this driver board seems to work fine. So what was I going to try? I was going to try with the small board plugged back in, with the preamp board plugged back in. I was going to try and change the muting transistor. So I did change that already, but that was when I was having issues with the driver board. So I'm going to change the muting transistor once more for BD139 and see whether the problems go away or not. Hello from Russia. Hello to Tina Charles. Hello. Okay, let's wait for the rail voltage to sink back down again. We've still got 45 volts on the rail, so that needs to disappear first before we do anything. Let's short it out. I'm getting lazy and bored. There we go. Right, so let's change the muting transistor then once more. And once we change the muting transistor, I can go ahead and power it up with the preamp board attached again. Can't you just short the muting transistor and discard the problem? No, that's not how the muting transistor works. The muting transistor works really, really strangely. And I don't want to short the muting transistor. What I want to do is I want the shorting transistor to work properly. In my head, the muting transistor should mute the drive to the FETs until the preamp board has come to life. And that should prevent that bump in the preamp board when the preamp board turns on from reaching the FETs. That's, I think, what should be happening here. Okay. So let's get our preamp board and let's make sure we slide this in with the pins in the correct locations. I may have actually killed some of the things on the preamp board here, so no, so it still has that massive bump on it. So the drive still has that horrific bump on it, so it's not the muting transistor that's the problem there. So the muting transistor isn't the problem. Jesus Christ. This is seriously annoying. I might have to turn to a second opinion on this one from somebody I know, Gordon at Amp Doctor. Might have to just see what his opinion is on this because I'm starting to struggle now. I'm really starting to struggle now on this. $224J63. So the only other thing that I can think it could be now, these preamp boards, you see these blue film capacitors, these have a tendency to go bad. So it could be one of these blue capacitors here that's causing the problem. So what I might actually do is I might remove the driver board here just to get that out of the equation for a minute. And I'm going to flip the board over, I think, like this, so I can work on from the bottom here. And I think I'm gonna try and probe some of these pins that are for the film capacitors as it's turning on, and see whether I can see what the problem is there, going by those. There's no difference in current draw between when the preamp board's disconnected and connected now. The current draw is exactly the same, interestingly. Something seemed to be drawing current then, for some reason. Not sure why. Okay, there we go. So, right. Very carefully slide this back in. Very, very carefully. Making sure the pins are in the exact correct places. Don't want a repeat of last time. Okay, so there's the bump. Okay, on this pin of the driver board, here is the bump. You see that? Let me zoom in on my scope a little better. Right, here's the bump. It shouldn't be there. Oh no, wait, sorry, that's the positive rail, so it's on pin 4. Bottom! Bottom! That's the issue, right? So we need to look for that on the preamp board. So I'm thinking it might be on a film capacitor. So it's not on that one. So let's keep going and have a look at all these film caps and see which one's the bad one. Nope, it's not either of those. Let's keep going and have a look at these ones. So there's 3 in a line there. 2 bigger ones and 1 smaller one. Okay, there's a bump on this one. Small bump on this one. On this one, there's a small bump. Small bump. Small bump. Nothing. Nothing. Okay, so there's a small bump on these ones, these big ones here. Alright, let's keep going. Let's have a look at the other ones here. Okay, big bump on this one. But we're looking for a capacitor that has DC on one side and the bump on the other side. So because we need to know where the bump originates from. You see? Big bump on both of those two there. Big bump on that one. No bump on that one. That's DC. So let's check these slightly larger capacitors now. Bump on that one, but not that side. Okay. No bump on that side. Big bump on that side. Big bump on that side. Bit of a bump on that side. Huge bump over here on CF3. Yeah, the reason the blue light is turning on and off every time is that's because I'm touching the remote pedal with my foot down here. So obviously the blue light comes on and then I turn it off again. So I need to keep power cycling the bump every time. So I'm turning the amp on and off to get the bump to happen. That's why it's doing that. Okay, so because I'm struggling to locate where the bump is happening, what I might need to do is I might need to remove every single op amp from the preamp board, take all the chips out, and then I can try and locate where the bump starts from. Because that's the problem, I need to find where the bump is originating from in the first place. I wonder whether it's a difference in the. So I've just had a thought actually. So the op amps in the preamp board are obviously powered by plus and minus 12 volts, for example. Now, if the plus and minus 12 volts, if they build at different rates, then one side of the op amp will turn on a fraction before the other side. So that might be causing an issue perhaps. So I'm just going to compare the positive 12 volts to the negative 12 volts and see maybe whether that's got anything to do with it. So if I go along to here, if we probe the positive and negative voltage, I need to turn my other probe on as well. Okay, so we've got the positive, so that's a negative 15, ground, negative 14, so that's the output of that. So that's negative 14, and we've got 13 up there. So there is a slight difference. We've got positive 13 and negative 14. So if we do both of those, it's possible that they're building at different times, at different rates. Yeah, I'm still going to test it on the subwoofer in the background, but I don't know if I'm actually going to get to complete it at this rate. Yeah. Yeah, if only I had another preamp board to confirm the issue was with the preamp board. That's the beauty of having lots of spare parts. If I had another one of these preamp boards, I could just slide that other preamp board on and confirm if that's the issue or not. Because I could be fooling around with the preamp board all this time and it not actually be the problem there. Last night I did have the preamp board attached, so when it went bang. Okay, so yeah, what I'm going to try and do next then is I'm going to go ahead and remove all the op amps from this driver, from this preamp board here, and hopefully that will allow me to pinpoint where the issue is starting from, hopefully. So there's 1, 2, 3, 4, 5, there's 6 chips to remove here, so I'm just going to go ahead and do that real quick. Yeah. Yeah. So if there's any flex, yeah, if there's any flex on the CA glue on the spider, then basically that's going to cause like a rocking effect and another resonance on the glue itself. So yeah, the glues attaching the spider to the coil former need to be absolutely hard as nails. Yeah. Yeah. You can come and because yeah, I can do another. Well, like I said, I can do another weird intermediary repair on the spider to just get it working for another few weeks for you. But at the end of the day, like I said before, when you dropped that round to me, that was really a recone material anyway. Yeah. Say again? Oh, the 21. Yeah. I know. The pictures are so funny. I can't believe that they forgot to do that. Yeah. Yeah, crazy. Yeah, I mean, there's not really anything that I can do with those ones, because to be honest, in order to use those coils again on a DD speaker, you have to fit a new spider. Now, Digital Designs won't supply me with spiders on their own. They only supply spiders attached to their coils. So I can't get new spiders for them. So maybe if you can get a spider from a different brand, and you can make a hybrid woofer with a different basket, that would work. But you can't put a different brand spider on the DD ESP basket, because the DD ESP basket spider landing is much bigger than any other spiders that I've seen. They don't fit on there. So yeah, you can maybe use those coils for something, but you have to maybe get some spiders from some other manufacturer, maybe like Ground Zero or something like that, maybe B2 Audio's type of spider, and then you could maybe make something with it. But yeah, but you have to remove the spider from the coil very carefully, so as not to damage the former. It's a bit of a headache. Yep. Yep, I think so. Yeah, no problem. Just to let you know, me and Pooven are both in America from the 12th of August till the 15th of August. So probably if we put an order, it'll probably be coming like at end of August or maybe sometime in September. So, yeah. From 12 to 19, me and Pooven are visiting DD in the America. Yeah. So maybe we can put one in the suitcase, put some Rico in the suitcase for you. Maybe. It's pretty lightweight. So maybe we can just take one Rico in back for you. But I'll see. Yeah. Maybe I'll see what I can do. All right. Nice one. I'll speak to you soon, yeah. No problem. Bye. Yeah, sorry. I decided that I might as well leave the sound on for that phone call because it wasn't a personal call. It was something. It was just something regarding Recone kit. So I thought, may as well just leave the sound on, seeing it's kind of work related and it's nothing personal. Whoop, got a big wasp in here. When did you get interested in audio and why? I got interested in audio when I was probably about 12 years old, and my mother gave to me her old Rotel hi-fi system, and it had a really big bass knob on the front, and the speakers had a good excursion, so when you turned up the bass knob you can see the speakers moving with a really big excursion, and I was fascinated by watching the speakers move, and I loved to play different music and turn up the bass knob and watch the speakers move like crazy. I thought it was really cool. So that's probably where it all started in terms of interest in audio. And then I tried connecting many speakers to the Rotel Hi-Fi, like lots and lots of speakers here, all in parallel. And then obviously eventually the Rotel stopped working because there's too many speakers connected together in parallel. So then I learned that that's not a good way to do it. And then I learned about ohms and impedance and how to do it correctly. Yeah, I just learned from there really. Almost done taking the op amps off this board. And then what I'm going to do is I'm actually going to put the main amplifier board back in the heatsink, because I just realised that because it has the rails which slide this board in, it will prevent me from putting the wrong pins in the wrong holes again and causing more damage like I did before. So yeah, let's remove the op amps from there. Just tuned in. What's the problem with this amp? Oh man, don't get me started. What isn't the problem with this amp? If the YouTube live stream lets you, then skip back a little bit in the live stream to see the problem happening. Is when you basically, this is the preamp board for the amplifier. When you attach this to the rest of the board, the outputs, they spike a bit of DC on the FETs, and that eventually blows the FETs up when you keep turning the amplifier on and off. But with this board removed, the amplifier works perfectly fine. So there's obviously some problem here with the preamplifier board. So I'm just trying to figure out exactly what the issue is here. And we're having some headaches finding out what the issue is. And in trying to find out the issue, I also made the mistake of causing more damage by accidentally sending rail voltage to the output section ground, which killed the driver board, the KA7812s, and burnt a trace on the board and a bunch of other crap. Another call. Okay, so yeah, that's all the ICs removed. So let's plug her back in. Now we're looking to see if the bump is still there or not. So basically, yeah, I also broke a small resistor here, which I didn't mean to do. Yeah, I'm not having a great day today with this. So in removing one of those ICs, I also managed to damage one of these small resistors here, but that's okay because we can just replace it. It's only a resistor. It is what's this value resistor here? I mean, this resistor might have been bad already. The fact that it broke apart so easily. So this resistor is looking like it's purple orange. What is this? It looks like yellow, purple, orange, gold. So can anybody just do me a massive favour, because if I try to Google something, my live stream will probably crash. Can anybody just tell me what yellow, purple, orange, gold is on a resistor? Thank you. Massively appreciated. If anyone can just quickly Google that for me. Otherwise the stream will probably die if I try to Google that. $47K. Thank you very much to Basehead. Okay, so that's back in the board. So let's see now then where if the bump is still present anywhere on the board now that we've removed the ICs. David, how old are you? I'm 26. Okay, so let's have a look. Okay, so it looks like we don't have the bump there anymore, which is pretty cool. So the bump isn't there anymore, so now that we've removed the op amps. So that's interesting. So what I'm going to have to do now is the tedious task of going through every single op amp pin and seeing whether there is a bump on any of the pins here. If I can't see a bump anywhere, then I'm going to have to assume that it was a bad op amp, or it was to do with the op amps turning on. Not found any bumps yet. So no bumps yet. So I think it probably it was one of these op amps then that was giving a pop when it turned on. I don't know if we should have DC voltage there, actually. That's interesting. There's DC voltage on this pin here, similar to actually how we have the rail voltage over here. So that's on pin 3. I mean, maybe we should, because that was weird. How we have rail voltage on it. So maybe there should be rail voltage there. Okay. So that was pin number 2 that had a bit of DC on there. So that goes to R5C. That goes to ground. That's weird. Why would we have DC on the ground there? I'll plug this back in, but again, have to be very, very careful to get this the right way around. Three volts DC on that one. That comes from here. And that one has the rail voltage on it. Yeah, so that is correct. That is supposed to be there. Okay. Right. Okay. So there's no bumps or pops anywhere on any of the IC pads now. So what I'm going to try and do is I'm going to try and find some donor boards that has a bunch of these op amps on it, so I can go ahead and do a replacement of those. We need 2 of these JRC 074Ds, and we need 3 of these 4558Ds. So let me just go and grab a donor board and have a look and see if I can find some replacements of those. Maybe that'll solve it. Hello, Jesse. Okay, so I found a couple of boards over there that had a few bits on there I can steal. So basically, the chips that I've got here, these ones are 074D by JRC, and I'm assuming that those are the same as a TL074C. Even though it's a 074D, I'm assuming that I can use a 074C. And then for the 4556, oh, I've got 4556 and a 4558. Fuck, which one went where? Hang on a minute. Well, we've got two of these areas that do deal with, so the 4558s are probably the ones that... Yeah, the 4558s go over there and the 4556 goes over here. Right, okay. So I think I can use the TL074s in here instead. I think they should work. Yeah, so let's go ahead and remove the TL074C chips from here. And yes, to whoever said I should get a chip puller, they're very much correct. I should probably get a chip puller. That would help me out greatly here with stuff like this. Okay, that's the two 074s. I think they should work in the board. And then this amplifier, this one has one of the 4558C chips that I need, but it only has one. And I'd like to try and keep those two chips the same if I can, because they're actually doing a similar job. But what the hell, let's go ahead and remove this one anyway. Okay, I don't think I have any more chips that will work with this. So I've got the. I can go ahead and probably put the 74Cs in just quickly now, but I don't think I've got any of the others that I need. So I can put two 74Cs. I think they're probably the most important ones. I think. So well, I'm actually just going to go ahead and put the 74Cs in first. I'm going to power it up and see whether there's a bump on either of these without the rest of the chips in the board. Because that will tell me a lot about what's going on here. It's so hot here today in the UK, I'm literally just sitting here roasting my arse off. Oh, I'm a bit confused, mate. Oh, there was 3 7.4. Oh, okay, well, shit, whoops. There's actually 3 7.4s that I needed. Should be another one somewhere, maybe. There we go, there's another one on this board. Let me just grab that one quick. Okay, so it's at times like this when the Hakko desoldering gun will be becoming really handy. This is the times when it will make my life a lot quicker and a lot easier. So yeah, maybe it's about time to invest. Why did you decide to work for DD? Didn't really decide as such, I just kind of fell into it. Mostly my YouTube channel was like, because it was like sort of semi-popular, and I was really interested in the brand, and I became good friends with Proven, who was a distributor at the time. And yeah, I just started talking to him, and he just started, he sort of said, you know, with your channel and with your knowledge in the car audio scene, I think it would be good, it'd be cool for you to start dealing DD to the UK. And I was like, okay, yeah, sure, that sounds great. So yeah, that was how I became a dealer for DD in the UK. To test a repaired amp with speakers. Yes, for the endurance test, I run the bench test on a static load, which is a much harsher environment for the amplifier than a speaker. A speaker doesn't really present a very heavy load for the amplifier unless it's in a big box and it's a big speaker, and that would make lots of noise. So I use a static load, which is a much more stressful environment for the amplifier to run under. Okay, so that is the that's the 7/4s soldered in. So what I'm going to do now is I'm going to slide it back into the amplifier, and I'm going to power it up. I'm going to see whether there are any pops on the audio line like there was before. Let's have a look and see. What portable oscilloscope do you recommend for setting gains and clipping detection? I don't. The cheap ones from eBay that are like 40 quid are fine for doing that sort of thing, really. Okay, let's see. No, it still has a bit of a bang on it. Still has a pop. So the pop isn't related to the op amps or the pop amps. That's really interesting. It's obviously something around the op amps that's causing the pop. It's much smaller than it was, though. I think. So what I'm going to do is I'm going to put the driver board back in, and I'm going to see whether that pop causes a glitch on the drive like it did before. Bevy's got that non-audio related board repair done. So relieved and happy. Playing on it now. Actually, that's great, man. Good work. Nice one. It's nice to hear when other people have success, even if I'm not. Okay, so driver board is back in. The amplifier was charged up just then. It wasn't turned on, but it was, the rails were charged, so I have to do that very carefully. So I'm going to probe the low side drive, and I'm going to see whether we get any glitches as it comes on, like we had before with the new op amps in there. Okay. Yeah, so it actually does. It turns on fully for a bit first. And if we probe the oscillator output pin, we can see that happen much closer up. Yeah, so I'm still not very happy with this. I still don't want to put the FETs in just yet, because if I put the FET, if I reconnect up the gate resistors, that might blow the FETs. The fact that that turns on fully like that. And if we remove the input board now and do it again, it'll probably be all super smooth. Ow! Just got a nice electric shock then from the rails. That wasn't too nice. Just trying to avoid doing that again. Yeah, it comes on super duper clean. Poof. So, okay, still problems then. Some problems still on here. Fuck, don't know what that could be then. Unless it is just these film capacitors. But yeah, sadly, we're probably gonna have to leave it there for today. As can't seem to, that's just going to be chasing a rabbit down a hole. So yeah, I might have a speak with a few people and see whether they have any suggestions, rather than just trying to change everything on this preamp board. So yeah, thanks for tuning in, guys. And you can follow this repair probably next time. Just keep an eye on my channel, and you'll see when I next start streaming with the Sundown SCV-6000D, and you'll then be able to see the progress with this one after I've spoken to a few people. So thank you very much. Take it easy.